So I'm going to add a little piece and a regular piece of sodium to the water. You'll see it react almost immediately. The gases that you'll see, the bubbles coming out, that's hydrogen gas. Now, the steam that you're seeing, that's steam. That is caused by the rapid release of a lot of energy, which is causing some of the water on the surface to turn to steam. So that's not hydrogen, that is steam. Notice that I put in an irregular piece of sodium, and what you're seeing there is a perfect sphere. Why? Because a perfect sphere is going to have the smallest amount of surface area. Pretty soon it's going to explode. So we'll talk about the reason why it exploded in my explanation afterwards. In this next part, I'm going to add some phenolphthalein, which is a indicator that's going to tell us that sodium hydroxide is being formed. Okay, so by now you realize that there are 5 types of reactions. This is going to actually involve 2 of them. The first reaction that we have going on is a single replacement reaction. You've got sodium solid reacting with water. Now there's a reason why I'm writing water like this. It just makes the reaction a little clearer, because what you have is sodium, and sodium is going to react with the hydrogen. Since sodium is way up on the activity series and hydrogen is way down, then yes, this reaction does occur. So the sodium is now going to react and will replace the hydrogen, so that now it appears to be dancing with sodium hydroxide, which of course it's really not dancing. Well, it is dancing, but it's not. They're not a couple. They're just dancing as friends. That's what we mean by aqueous. And the hydrogen is kicked out. Now remember that hydrogen is one of our 7 diatomics. So hydrogen is not by itself. Hydrogen is going to have a little 2 by it. And you saw it. It was a gas. You saw the bubbling. You didn't see it. You didn't see the gas coming out of it once the sodium got to the surface. That was actually steam being produced by the fact that this is a very exothermic reaction, and some of that heat is being used to convert the water into steam. So that's our molecular equation. In our total ionic equation, sodium solid, and I don't think I balanced this, did I? 2 sodium solids plus 2 hydrogen ions. And you see, that's why it's so important to, in this case, when water is reacting with a metal, to state that water is in the form of HOH, and that makes it a little easier to split it apart. See that? So, to form 2 sodium ions, 2 hydroxide ions, and there is our spectator ion plus hydrogen gas. Hydrogen gas. So our spectator ion is hydroxide. It is. Now, you did see the presence of hydroxide. When the solution turned pink, that was telling you that hydroxide was being created, because that chemical that I added, phenolphthalein, and when we talk about acids and bases, we will bring that back up. That chemical that I added tells you of the presence of hydroxide. So it turned pink because of these hydroxides that are being created when sodium is tearing apart the water molecule. So our net ionic equation would be sodium plus 2 hydrogens to form 2 sodium ions plus hydrogen gas. Applying this to our understanding of oxidation and reduction, oxidation, who's going up? Sodium's going up. 2 sodiums, 0, are going up to 2 sodium positive 1s. Oil rig, oxidation is losing, so we got to lose. How many electrons? Well, sodium has to lose 1 electron in order to become plus 1. So you have 2 sodiums, they're going to be losing 2 electrons. Reduction, hydrogen, the 2 hydrogen ions are going to become hydrogen gas. So they are going down in charge from plus 1 to 0. Remember, anything in its natural state is 0 charge. So each one of those hydrogens are going to have to gain an electron. That's a total of 2 electrons. And 2 electrons are given, 2 electrons are taken, and that's it. That's it. Those are the 2 half reactions in this. Now, I mentioned that there was another reaction in this, and that's the reaction that caused the explosion. Because you have hydrogen gas being produced, plenty of oxygen gas in the air. What do they form? Water. 2 waters, to be exact, in the form of gas, probably. So I think that balances out. This is a synthesis reaction. Remember, there are only 2 types of reactions: double replacement, synthesis. Redox. So synthesis is an example of redox, so is decomposition, single replacement, and combustion. Double replacements are precipitation, acid base, gas producing. Now, how is this a redox reaction? Well, let's look at it. Hydrogen in its natural state, 0. Oxygen in its natural state, 0. Hydrogen as part of a compound, plus 1. Oxygen as part of a compound, negative 2. So hydrogen is going from 0 to 2H positive. It's going up. It is going up. That's called oxidation. So it goes up by losing electrons. So the electrons it gained from the sodium, it now loses to the oxygen in the air. And of course, oxygen is going to gain those 2 electrons to become O negative 2. So, 2 oxidation reduction reactions.